everyone, my name is Miss Connolly. I started making some videos for my 5th graders, and then one of them helped me create a YouTube channel. Shout outs, you know who you are. Anyways, I wanted to make sure that they were learning during this crazy time. Then I decided that these videos could benefit more than just my students, and here we are making videos for grade levels K through 5. If you need a topic covered, please email me, connollymath@gmail.com. It's keeping me occupied. I feel good that I'm helping you. Parents, if you need help remembering how we learned something or figuring out the new way that we're learning math, please feel free to reach out. These videos are to help you as well. Everyone stay sane right now. So in this playlist, you are going to find a video that teaches the 4th grade multiplication strategies, where we break both numbers apart using the area model. We keep one number whole. We change one number or change one factor and then adjust back. So make sure you watch those because they're really important for understanding what's about to happen. I'm going to go over the U.S. standard algorithm for multiplication. This is not taught until 5th grade in Massachusetts anyways. And the point is that we really want kids to understand what's going on. We do not want you just memorizing a procedure and skipping all of the other strategies that get you there. The standard algorithm is a great strategy that you can use, but there's a lot of other ones, and some of them are more efficient that you can do in your brain as well. So this is just one out of many strategies. The ones that I did in the last videos are reviewed and refined in 5th grade. We don't learn this until halfway through the school year. So those ones are important too for 5th graders. All right, so let's think about what's going on with the U.S. standard algorithm for multiplication. When we have a standard algorithm, and there's many standard algorithms out there, this one is for the United States standard algorithm, we are going to line up by place value, so always make sure that your digits are lined up. And what's going to happen, just like in addition and subtraction, we're going to start over here in the ones place. But what's really happening, what we're about to do, is we're going to do 38 times 2. And we're going to do it in steps. Okay, so it's kind of like keeping one number whole in those other strategies where we do 38 times 2. So let's write down what's going on here. So in the U.S. standard algorithm, you are going to start here, and you are going to multiply 2 times 8. Okay, so I am going to write this down over here. We're doing 8 times 2, which is 16. Okay, what happens is you are going to write the digit 6 down here, but then you have an extra group of 10 that you need to carry over here. So we're going to write it up here. Okay, you see your extra group of 10 here? This is the 16 that's going on. The next step, once you've multiplied ones place by ones place, you're going to take the digit in the ones place and multiply it by the tens place. So what's going on now is we're doing 30 times 2, and then we're going to add in the group of 10 that's floating up there, and you'll see what happens in just a second. So we are thinking about 2 times 30, which is 60, plus 1, which is, or plus 10, sorry, which is 70, and that's why we get 76. The beauty of the standard algorithm is you don't really have to think about place value. We think about multiplying the digits as 2 times 3 plus 1, and that's why we're ending up with a 7 here. But like I said, you need to understand what's going on. So we just did 30 times 2, and this step here, all the stuff in purple, represents 38 times 2. Do you see the 38 times 2? So 38 times 2 is 76. That's what just happened in this purple step. Okay? You can see it, you understand it, that's what's going on. So then, if you're in my class, ever in the future or right now, I always make sure that we either erase or cross off what we've carried from the previous step, because it can get confusing in the standard algorithm. And let's move on to the next step. So we just did 38 times 2, and now, sometimes I cross that off too so don't get confused. Now we're going to be thinking about 40 times 38. So the next step is going to represent 40 times 38. So you see the keeping one number whole, you see breaking up the other factor. We're going to keep track of that stuff here. So since we're multiplying by 40 and not 4, you always have to put a 0 here. Why? Because you're not doing 4 times 8. You're really doing 8 times 40. That's what's happening here. 8 times 40, because it's in the tens place, which, as you know, is 320. So we need a 0 here because we're not doing 4 times 8, which would be 32. If you put the 2 here, that's not what's actually going on. So every single time you come to the tens place, you're going to put a 0 here in the standard algorithm. Then, in 320, we have a 2 in the tens place. So what I'm going to do is put the 2 from the tens place here, and I'm going to carry that group of 300 over here. Okay, so that 3 stands for 3 groups of 100 that we're going to be adding in just a second. Now, the next thing that we're going to do represents 30 times 40. You see the 38 times 40, which is 1,200. So over here we have 40 times 30, but we're going to think about it as digits. 4 times 3 is 12, but we have to add in those other 3 groups of 100 that we carried from the 40 times 8. So now we're going to be doing 1,200 plus 300, which is 1,500. So we put the 5 in the hundreds place, and we put the 1 in the thousands place. So this step here represents, I wrote that too low, 38 times 40, which is 1,520. Now, in the other strategies that we went over, you know that once you've split up, we kept 38 whole, we split up the 42. Now we combine the 2 subproducts to get the total. So, in the standard algorithm, you're going to add here. So 6 plus 0 is 6, 7 plus 2 is 9. There's nothing to add this 5 to, or the 1. So we get 1,596. You see how the numbers are broken apart down here. This stood for 38 times 40. So you can see the 38 times 42, and that's what's going on in the standard algorithm. As you move forward with the standard algorithm, we're going to think about it as multiplying the digits, but I wanted you to have a solid understanding of what's happening when we use a standard algorithm for multiplication. There is a standard algorithm for subtraction video up if you want to make sense of that as well. And I'm going to be making one for addition because that's really important to understand what's going on too. All right, so let's look at another situation when we are multiplying. I'm just doing 2 digit by 2 digit. When we get to more time, when I have more time, I'll be doing 3 digit by 2 digit, and we can think a little bit further about that. So let's think about 47 times 98. And let's think about what's actually happening here. We're going to start in the ones place just like last time. We know that the first row is going to represent 47 times 8. Okay? So this row here, I'm going to do it in green, is going to be 47 times 8. Let's pay attention to what's actually happening. So we are going to multiply 7 times 8 first. We get 56. We're going to put the 6 in the ones place, and we're going to carry those 5 groups of 10 over here. Then, this step actually represents 40 times 8. So 40 times 8 is 320, but we still have the 50 from our previous step. So we're going to do 40 times 8, which is 320, plus 50, which is 370. In the standard algorithm, like I said, you're just thinking about digits. So that's why people prefer it, because you're just thinking about 4 times 8 is 32, plus 5 is 37, and we jot that down here. But you can see what's actually happening. We did 7 times 8, which is 56. We did 40 times 8, which is 320, and then we got 376. Okay, so that's what's actually happening. It's 8 times 47. Okay, just like last time, get rid of the extra stuff here. Moving on to the next row, you're always putting a 0. If your parents tell you just to write here, don't listen to them, listen to me. The 0 goes here, it represents something, it's not just a blank space. Okay, so always, always, always a 0 goes here because we're actually doing 90 times 7 next. So this next row is going to represent 90 times 47. Does everyone see the 98? 47 times 98 might remind you of keeping one number whole. So just like we did last time, always, 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 this is a mistake kids like to make. You like to start going here because it reminds you of the addition standard algorithm, but you're going to come back here and start with 90 times 7. In the standard algorithm, you can think of it as 9 times 7 to help you. So 90 times 7 is 630. So what we're going to do is we're going to put the 3 down. See the 30? So 9, let's think of it as digits now. 9 times 7 is 63. The 3 goes here. The extra 6 groups of 100 are going to come here because we're going to add them into the next step. So we just did 90 times 7, 630. Okay, you see this starting to form here. Then you're going to do 90 times 40 plus the 600 from before. Okay, we'll think about this as 9 times 4 plus 6. That's the beauty of the standard algorithm. So when we think about 9 times 4, we get 36 plus 6 is 42. But what is really happening is 90 times 40, which is 3,600. We're adding the other 600 in, so we get 4,230. So that's what's actually happening here. Just like the other strategies that I went over, the 4th grade strategies that we refined in 5th grade, before the standard algorithm, you're going to combine your 2 subproducts. 6 plus 0 is 6. 7 plus 3 is 10. We're going to carry the 1 over here. 2 plus 3 plus 1, 6. 4,606. And I will be the first to admit that I do make mistakes sometimes. So if you see a mistake in my math, let me know. I'm talking, thinking, drawing all at the same time. Okay, so that's the understanding of the standard algorithm. Now I just want to show you the steps without all of that chitter chatter so that you can remember them. Okay, so we're going to do the steps of the standard algorithm. I hope that this helped you understand what was going on in each part of this. But now let's practice the steps. And you can grab paper and do it with me, or pause it, do it, and then check with what I do afterwards. So let's do 58 times 37. So we're going to start over here in the ones place. That's how we do the standard algorithm, the US standard algorithm for multiplication. You're going to start with 7 times 8. Just think about it as 7 times 8. You're going to put the 6 down, because 7 times 8 is 56. Carry the 5. Okay? I know that it stands for 50. I just want to teach you how we think about this with digits. Okay, next we're going to do 7 times 5, which is 35. We add the 5 in and we get 40. So when we think about this, 58 times 7 is this step here. Okay, so I'm just going to check 350 plus 56, 406. When you get to the next step, not negotiable, you're going to put the 0 here because of what it represents. I want you crossing off the number that you carried so that you can, so we don't get mixed up with what's going on in the next step. So we put the 0 down here, you know what it represents, we just went over that. We're going to start here. And I like to cross this one off so that I don't forget that I already did that step. You're always coming back this way. 3 times 8, going back that way. 3 times 8 is 24. We can think about this just as digits. You can set place value aside while you're operating, but I want you to remember what it really means. Okay, so we did 3 times 8, 24. We put the 4 down, the 2 comes next door. Then we're going to multiply 3 times 5, which is 15, plus 2 is 17. So this step represents 58 times 30. I'm just going to double check I didn't make any mistakes. 1500 plus 240, yep. And then the last step of the standard algorithm, just like the other strategies, is you add the subproducts together. And that is the standard algorithm for multiplication with 2-digit by 2-digit. If it's 3-digit by 2-digit, we're going to do the same thing. We're just going to extend our steps to the next one. I'll do one example of that because I think it's important. Let's do 308. I'm sneaking a 0 in there because that's where kids get confused, times 42. So what this first step is going to represent is 2 times 308. First we're going to do 2 times 8. Then we're going to do 2 times 0 groups of 10, then 2 times 300. So this step stands for 2 times 308. Okay, so 2 times 8 is 16. You carry the group of 10 up here. 2 times 0 is 0, plus 1 group of 10, 16. Well, it was 1, but now we have 16. And then 2 times 300, 2 times 3 is 600. So we're going there. Okay, not negotiable, cross this off. I like to do this. And when we get to the next row, you don't throw your marker, but I do. You put a 0 here. Okay, because you know that we're multiplying by 40. So this row is going to represent 40 times 308. So our first step would have been 40 times 8, which is 320, ends with a 0. It will every time, so the 0 goes here. So 4 times 8, we're coming here, 32. Now, don't get confused. After you multiply here, you carry to the very next place value. Don't go anywhere else. Okay? 4 times 0 is 0, plus 3. We put our 3 here. Then, we just make sure we finish with 40 times 300. So what we're going to think about it is 4 times 3. 4 times 3 is 12. 40 times 300 is 12,000, just so you know why that ended up there. It all makes sense when you think about what's actually happening. And then we add our subproducts together as usual. And then we're done. So parents, if you catch your student doing this, I would just want to make sure when there's a 0 involved, sometimes the students want to go 4, pretend the 0 is not there, and do 4 times 3. And they multiply by what they carry. We just want to catch that early so that they're not developing a habit, because when the 0 is involved, it feels a little bit different to them. So if you have any questions, please email me, conleymathathome@gmail.com. I hope that this helped with your understanding of what's happening with the standard algorithm. I know a lot is going on. I have a lot going on over here. So if you have any questions, just reach out. Okay? Bye.